This is problem number 1 on the sample test problems for test number 2. The amount billed to a residential customer by a natural gas utility company depends on the number of CCF, hundreds of cubic feet, of gas used that month. A customer who used 10 CCF of gas was billed $30.75, while a customer who used 15 CCF of gas was billed $40. A. Express the amount billed B in terms of the CCF of gas used G, assuming a linear relationship gives a suitable model. So first thing I'm going to do is go ahead and make a table here. My table normally is X and Y, but in this case we don't have X and Y, we have some different letters, so we're going to change it. Let's see, it says we want the amount billed B in terms of the gas used G. So that phrase, the in terms of phrase, always tells you that this is the independent variable here. So the gas is supposed to be the independent variable, which is over here. That must be G, which makes B the dependent variable, and that's our Y. So we'll go ahead and put in a G here and a B here. And once we've done that, we can fill in the two data points that we're given. We know that 10 CCF cost $30.75. So 10 CCF of gas cost $30.75. And then the other point is 15 CCF at $50. 15 things of gas cost $40. All right, and so if we want to find the equation of the line, the first thing we should do maybe is find the slope. So the slope is normally the change in y over the change in x. I'm going to replace my letters. This is now change in b over change in g. So we're going to subtract the cost, the money, the bill. So we've got 40 minus 30.75, and divide by the change in G, the change in the amount of gas that we used. Again, make sure you put your Y's on the top. In this case, that's the B's. And also make sure you subtract in a consistent order. So upstairs, we did 40 minus 30. That's this order, which means downstairs, we better do the same order, 15 minus 10. Okay, let's go ahead and clean this up. So this is $9.25 divided by 5. And I suppose we can just get some decimal if we are lazy and use the calculator. So 5 into 925. And we get 1.85. So that right there is the slope. And we'll start using our y equals mx plus b equation. And then we'll go ahead and change the letters around. We don't have y, we have a capital B. M we just figured out is $1.85. And x is not x, it's now g, plus, and then there's a lowercase b there. And if we wanted to find the value of the lowercase b, all we need to do is plug in one of the points. And so, for example, we could plug in 15 and 40 for the G and the B. So let's do that over here. Instead of B in that row, we have 40 equals 1.85 times, and then G is 15, and then plus some unknown little b. So let's go ahead and multiply 1.85 times 15. We get 27.75. And then we find B by subtracting the 27.75, and we get 12.25. So don't forget to write the final equation once you've got the slope and the B value figured out. So the final equation is capital B equals 1.85 G plus the little b that we just found was 12.25. Part B, use your equation from A to determine how many CCF of gas were used by a customer who was billed $59.98. So we're going to use that final equation, the one that's boxed. And we know that we're supposed to be billed $59.98. You have two choices. You either plug in the $59.98 for the B or for the G. The B is supposed to stand for bill, so that feels like we should plug it in over there. Also notice that in our table here, B is the money amounts. So sure feels like that 59.98 needs to be a B. So let's go ahead and plug in. So that equation here, now replacing the B with 59.98 and writing everything else again. 59.98 equals 1.85G plus 12.25. And the goal is to solve that equation for G. So we'll first subtract off the 12.25. So that leaves us with 47.73 equals 1.85G. And then finally divide both sides by 1.85. And I'll go ahead and type that into the calculator. So we're doing 47.73 divided by 1.85. And we get 25.8. So 25.8 is our answer for G, and that's 25.8 CCF. Part C, what is the slope of your equation from A? And what does the slope represent in the situation? So let's try that. So I think we found out the slope was 1.85. In order to analyze that slope, I think it's really important to write some units on it. So going back up above to where we found the slope, we saw that the slope was the change in B over the change in G. So the units for the slope are going to be the B units over the G units. The B units were dollars and the G units were CCF. So on the top we have dollars and on the bottom we have CCF. So this is $1.85 per CCF. And if I really wanted to put a number down there, I could put a 1. And then it's pretty much just a matter of reading that fraction. It cost $1.85 per 1 CCF. So we'll go ahead and box all that. That's our answer for part C. And then finally D, what is the B-intercept, the vertical intercept of your equation from A? And what does the B-intercept represent in this situation? So let's go back up to our equation that's in the box right here. So that's our equation, and we know that the B-intercept is this little b, which was 12.25. And that corresponds to a value of this guy equal to 0. So you get your y-intercepts when x is 0. We get our b-intercept when g is 0. So let's see, it was 12.25 is the intercept. I'll go ahead and say that's little b. And so the point that we're interested in here is 0, 12.25. You don't need to write it, but I like listing the 0 so that I have a sense of what's going on. And so what that means is that if you buy 0 CCF of gas, you will be billed 12.25. So it costs $12.25 for 0 CCF. And if you wanted to say something slightly different, you could say $12.25 is maybe the service charge. You pay that no matter what, and then you pay your $1.85 per CCF once you've already paid your service charge.